Alright. Okay, so now I believe the mic is hot, and I'm stepping on Winter Gatan music. Mine seems like we're looking okay. So we shall see what we shall see going forwards. Guess I could stop and check and make sure. Looks about right. I have to keep setting up the chat thing each time. My workflow is not very good yet, but we shall see. And I didn't get enough sleep. So that'll be my excuse if I do anything particularly dumb today. All right, so let's just go back to the waiting room. Yeah, the simulation is funny that they're supposed to be these two-celled creatures, but they have a lot of problems with the net result. That I think what we're looking at here is all northwest cells. They're supposed to be consisting of a northwest cell, a northeast cell, and a southwest cell. But in all cases, the southwest cells have died, and all of the northeast cells have collected over the west side of the grid. You can tell because the southwest fingers sticking out of each cell, the ones that are lighter colored, those are the ones that are looking for a matching cell. The darker ones are meant to be external skin, so they're not looking for another one. So those are all northeast cells looking for southwest cells and not finding any. And this is as far as I ever got. I mean, this still is pretty much the peak of the digital diamond replicator. And hey, Samter. There isn't. I'm sorry. The peak of diamond replicator multicellular success. Well, I mean, I did a 2x2, a 4-1 that survived a little bit, but anyhow, okay. Now I need to focus. So I guess we're about ready to go. And I think this is going to run long, but I will try to keep it under control. And Hey folks, it's T2sday. I'm going to do the same thing I did last time, which is kind of like just give a little mini talk in sort of the scientific academic head, because that's just sort of what I'm more comfortable doing, and I'm thinking being comfortable is a good thing. So I'm going to try to talk about this idea of flat reality, and I am probably going to completely muff it, but it does actually connect to T2 just in a way that's not super obvious. So, and it's probably all going to run long because that's what typically happens when I'm struggling to express something. So we'll see. I'll keep it as short as I can. So today we're going to do the background again. This is my academic talk mentality. You should always start with the beginning of the universe. Now, one of the things about this particular work and the stuff that I'm doing in general is that it comes in so many different directions. It's not like there's a single beginning of the universe. So I want to do a different one today and then talk about what I did in July and talk about the goals for August. Same as it's a T2sday update. So today I want to start with the living computation idea, and this has been, foundational to my thinking for decades now. Living systems and computational systems turn out to be the same thing. Now, a lot of what we've been talking about, like in the T2 tile project, for example, the digital replicators, the diamond replicators that people who are watching the live stream may have seen in the waiting room, are an example of using sort of living systems principles to inform the design of computational systems. But if we're saying they're the same thing, it should go the other way as well, that we should be able to take living systems, living organisms like, say, you and me, and use computational concepts, language, all that kind of stuff to understand and describe stuff that's happening to living creatures. And that's what I want to do today. Last year, Lou Wilson, Toad Pond, and I wrote this paper, Dialogues on Natural Code, and that it was exploring that idea that we are living systems, but if living systems and computational systems end up being the same class of systems, then this language that we use, that we're always gabbling to each other all day long, hearing and speaking or not listening, whatever it happens to be, and so there's, a fundamental question about language is, how does language acquire meaning? The alien comes down from space and goes, gigaflocko googie, and you say, well, and I'm sorry, I don't know what that means. But if you can take the code, the gigaflocko googie, whatever it was that I just said, and put it together with an example on gigaflocka googie, then maybe it means box, or maybe it means Raspberry Pi, or maybe I have a warranty claim from the alien, or the color red, or who knows what. But at least there's an example to work with, and you can start to close in on the meaning. So that's a lot of what science is that you're developing code, like laws of physics, F equals ma, or you're describing plants, a duck-billed platypus, lays eggs, but it's a mammal, or, whatever the thing is. So you have a bunch of stuff that's code, D-U-C-K, duck, and then you show an example in the real world about, here's an example of a duck, quack, and so people can learn language that way. But what if you want to talk about things that don't exist, that you can't point to an example all of them. Well, so what we do is, I'm going to make a game that nobody's ever seen a game like this. It's going to be so amazing. What we have to do is we have to pick some things that do exist and say not that it is one of those things, but that it's like one of those things. And you say, well, it's kind of like this and it's kind of like that, and it's got a little bit of extra. It's like the high concept in, Hollywood. It's like Die Hard meets Sleepless in Seattle or whatever it is. So here we're saying, imagine the universe as a cellular automata. Now, again, there are some famous people, some rich people, who want to go way farther than that. They want to say the universe is a cellular automata. Not only that, it's a deterministic, synchronous, etc. All these other things that strike me as, silly in the extreme. But we're not saying that. We're saying, no, we are coders. We're talking about building a framework for describing stuff. And the question is what's a good framework that allows us to do things, allows us to describe the sort of stuff that we want to describe effectively in a way that people may get, and so forth. And so we're saying, let's imagine the universe out there, whatever it is, this blooming, buzzing confusion. Let's imagine it as if, let's pretend, let's say, for purposes of modeling, for purposes of developing some code, that the universe is an actual cellular automata. And then you say, is it really? Is it binary? Yeah, whatever. No, the point is, as code developers, we have to pick language. We pick code, we pick nouns and verbs, we pick DUCK, we pick cellular automata, whatever it is, to describe things, and they're not all equally good at describing stuff. And even if they are equivalent in some sense, that doesn't necessarily mean they're as easy for people to learn or as intuitive or so on and so forth. So the idea is, if we could take some single spatially distributed model of computation, some spatially distributed, robust first programmable architecture for computation, then we could use that as a reference architecture to say, when I'm describing a machine, when I'm describing a thing, I'm describing it in terms of this particular model, that we're imagining the universe is kind of like that. Are we saying it really is that? No. Are we saying it's exactly like this? No. Are we saying that if we build a thing in this actual cellular automata, it will behave exactly the same as the universe behaves? No. But there may be useful connections. Anyway, whoops. I have to stop hitting my next button before I'm ready to go to next. Maybe it's a hint. So the idea is, if we could have a systematic model of computation that we could use to describe any physical thing, no exceptions, no bullshit, and if there was any question about, is this thing, this description, I'm saying, what is free will? Free will is a computation of this sort, and it has, these properties and this, and if people say, I don't get that, they say, well, we could unpack it further. We could implement a machine that does whatever it is. And my suggestion is that would be extremely powerful. I mean, almost dangerously powerful. That if there was a single uniform language that sort of truly was, in this sense, a neutral point of view, that you could describe anything. And it would be, describing it in crass physical terms, matter and energy, stuff piled up, fall down, do this, whatever, like that. It's no way meant to capture everything. But the point is, it's one systematic language that could cover everything. That is very, very powerful, I suggest. And so really, when I'm doing the mobile piece machine to build the T2 tiles and now on to the T2.5, in my mind, what I'm trying to do is actually build an example, a prototype of the spatially distributed robust first model that could be an underlying basis for saying, let us compute, for saying, well, you're saying blah, 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 I'm saying blah, blah, blah. I can explain what I mean in terms of a machine. If we take what you're doing and also put it into the same language of the machine, we can see the similarities and the differences. That's the idea. All right. So that's That's our background. Almost 10 minutes shot. What did I do in July? Well, I got ready for Black Hole, the Black Hole Quiet Box, this giant computer, $12,000 worth of hardware, which, according to the information that comes with it, requires a dedicated circuit, a dedicated electrical circuit, 15, 20 amps, whatever it is. And this studio that I'm in now, which is my intention, was to have the Quiet Box in here somewhere, because it's where I do a lot of work, as well as this stuff. There is no dedicated circuit here. I'm already using big old extension cords to pull power from other circuits around the house in here to get more power. So I was going to have to do something about it. So I asked around, and I found one of my Albuquerque friends had an electrician that they liked, Patrick, and I got in touch with them, and they came a week or so ago and put in new circuits. So here, this is two new 20 amp circuits. The one over here is 120 amp circuit, the one over here is 120 else. Sorry about the incredible disgustingness of the drywall. It needs a paint job bad. And here it is in the panel, back in the back of the house. Office quad left, office quad right. So that was a chunk of money, but I was happy to actually manage to do it, to get out in the world and so forth and deal with these people and just get it done. So Black Hole prepping, check. Faster and smaller. This is the other thing that I was doing today. So this is a picture, a layout of one of these little AI processors. They call them Tensix cores in the language of Tens Torrent. So that's why it's got Tensix there. This particular one is for the generation behind Black Hole called Wormhole. And so this is not quite right. These numbers are not quite right for what I am going to be getting, but it's close. It's enough to see the idea. And, there's actually 5. So these boxes up here, those are 5 different little computers, 5 different little processors that all work together. And this is a whole boatload of special purpose hardware that's meant mostly for AI and machine learning that I'm really not even going to be using hardly at all to begin with. I'm just going to be using these little regular things. And so we can kind of zoom in on one of them and here's the key thing. So GPRs, that's the general purpose registers inside the CPU. They're the things that are absolutely the best, fastest, easiest to access. There's 32 of them. Then there's this private little random access memory, which in Wormhole, on these particular ones, it's 2 kilobytes. I believe for Black Hole, it's now kicked up to 4 kilobytes, but it's still really small. And then there's the main random access memory, which is 1.5 almost megabytes of RAM. And that has to be shared amongst all these things and so forth. So there are these levels and levels and levels of different amounts of memory, and all of which, to my way of looking at it, are tiny, are super tiny. So I've been thinking a lot about how to re-engineer the Moolfeast structures and the Ulam shapes of code to try to fit into this. I mean, so once we get done, back up here, so one of these, the machine that should be arriving within the month has 480 of these whole things, 480 copies of this whole thing on 4 different circuit cards inside the machine. Yow. So in Ulam 3 through Ulam 5, and someday, hopefully soon, Ulam 6, the key data structure is called a Ulam ref. And I'm going to go way long here. I'm giving myself 20 minutes. I'm sorry, because I just want to go through this. And the ulam ref is a representation of a pointer. Now, like in an object-oriented language, and again, if we don't know what this is, it doesn't really matter, but you have pointers to things. You connect stuff together by pointing at them. And, in C++, for example, one typical thing that's done is you can point at an object, and if you want to have some information associated with that object, you put it like right behind what the thing is pointing at. But in ulam and the MFM, bits are extremely tight, and we may have an ulam object that is like 6 bits long, and there's no way we can put more information before it because those other bits are being used for something else. So the ulam ref has all of these data members in it so that it can act like a pointer, so that we can know what type of object it's pointing to, where exactly is it, how many bits is it, and so on. And the problem is, the ulam ref is huge. It's got 4 things that are pointers. And one ulam ref is 48 bytes long. So that's 4 times the size of an atom in this new model. These things are huge. And I'm afraid of this amount of hugeness because there's a lot of code to handle and I want to boil it all down. So in the last month, I created uref, not ulam ref, but uref, that is meant to be an ulam ref light, to try to get as much of the behavior and the generality of ulam refs by making the pointer as tiny as possible. And I'm still working on it, and the whole thing may not work out, but I've made a lot of progress, and here it is. The struct uref, it begins with a 16-bit data item, and that's all it's got. It's a 2-byte pointer. That feels good. It takes advantage of the fact that we don't need general pointers in MFM. There's only a small number of places of things that you really have any reason to be pointing at. So we don't need a 64-bit pointer for that, and so on. So that's it. I also set up instrumentation so that every time I build MFM X10, that's this little branch of the movable feast machine code that I'm using to try to develop stuff for Black Hole, and I have it all cross-compiling so that it's compiling it down to RISC-V code instead of Intel x86-64 code, which is what the machine I've got here is using, and measures how big the code is when it gets done. And so, when I was working, there's some data off the end here that I left out because it was way lower. But, already we're at 147 kilobytes of code space used up, like that. And that was at the very beginning. And it just shoots up from there. And again, these programs are doing nothing. They're just warming up and printing out a few values to convince myself like how big the struct is, things like that. They're doing absolutely minimal nothing. And, we've already gone from 147 kilobytes up to 155 kilobytes. Now, we have 1.5 megabytes of that big RAM up at the top, but a lot of different systems within the 10.6 processor use chunks of that memory for buffers and all kinds of things. So I'm imagining maybe I could have 1 megabyte of it to use for everything that I need. And so if we remap the y-axis here and put a megabyte at the top, then it doesn't look so bad. We've gone from 147 to 155. But again, this is just the tiny beginning. There's no physics here. There's nothing. So we shall see. But I'm glad that it's being tracked. It's writing out to a file so I can see how things go over time. And that's what I was doing for the last month mostly. And, having lots of fun. I did some other stuff too. And the goal for next month is, if I've done the arithmetic right, the black hole should arrive before the next update. And so the goal would be to have it running and be doing little teeny things like these on it. We'll see how it goes. So, the goals for today was electrical ready, P4 events, and have more fun. Electrical ready, electrical is ready. Had plenty of fun. Baby P4 events is not working, but the UREF is a big down payment on getting to something like that. So, okay, I'll take it. And that's it. So the goals for September 2, to have baby P4 events. P4 is the new 128-bit atom. Have the Black Hole Quiet Box, play with it, have huge fun, and hopefully, I have to put this back on, release Ulam 6 to tie a bow on the end of that. We'll see how it goes. Okay, 20 minutes today. Thank you so much for checking in, and I hope to see you next time. Alrighty. Now it's super hot in here, so I'm gonna turn the AC back on, and we're gonna have to live with it. I guess I'll mute the microphone a little bit. The problem is if I turn the mic on, then we get to hear the AC. So I wasn't sure if that was a net win versus just typing. I mean, I've been thinking about maybe I need to. Oh, okay. It may be about time to replace this air conditioner. It's been several years, and try to get a quieter one like that, so that conceivably it could even run during recording. I don't know. That just seems unlikely. This studio is not big enough to have theater HVAC, okay, David says mic off. I'm not sure if that's a request or a belated fact. I believe mic is back on now. Anyway, all right. So, was there any other thoughts that I actually wanted to talk about that I didn't get to? So I mean, so the flat reality stuff, that was like completely baffling, right? That made no sense. I bet. I mean, I've been thinking about these ideas of the importance or the power of us. It was it Leibniz? The one with said, gentlemen, let us compute, that they were imagining that the pinnacle of mathematics before incompleteness and incomputability results, that there could never be any any disagreement. There could only be misunderstanding. And so if people were disagreeing about something, they would just sit down, gentlemen, let us compute, and eventually they would realize where there was a misunderstanding, and then everybody would realize that there was no actual disagreement at all. And that Leibnizian vision, if that's the one who it was, I think it was, is, you know, completely ruined by incompleteness and halting problem results and all of that stuff. That there's stuff that mathematics, that is true that mathematics cannot prove within finite set of reals, blah, 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 the normal stuff. But what I'm proposing is a much weaker version that's kind of like that it will not, it won't be deterministic like mathematics. It won't have absolute proof guarantees of anything, because really it will be about code. It will be about, do we want to describe something? Yeah, and thank you, Ben. And the claim is that, you know, there is no true model. There's only models that are good in this respect but kind of bad in that respect, versus some other model which is good in that other respect but less good in something else, and so forth. We can rule out the perfect model. It cannot exist because of the nature of models, just like the nature of a map. The fact that a map is smaller than the thing that's mapped means it's incomplete, and if it was complete, it would not be useful as a map. So once we get this truth business off the table and we start talking like developers, is this model all in more useful than that model of the same stuff out in the world, or of overlapping stuff, not the exact same stuff, but, you know, stuff that's related to each other in some way. So the claim is that we could do that we could build a notional model of computation, that we could build machines that, you know, we could fill space with computational nodes, and we could program them, and we'd have to deal with getting power into the center of the whole thing and getting heat out of it and so on and so forth. But we could do that, and we could actually manufacture it using silicon and so on and so forth, and circuit boards and layers and racks, well, whatever it happens to be. We could make anything in such a model. We could have a single model, which we could then say, okay, you know, I think free will means this, code like this. And someone else says, I think I could just like a fly means this is a white box, you know, or whatever it is. And if we disagree on any of this stuff, then we just have to implement it a little more. Say, well, how would we actually do free will? Well, we'd put a random number generator inside, or, you know, whatever it is. We do whatever it is. But the point is, it gives us a path to implementability. And that's what I want to push, is that, you know, so much of discussion, of conceptual discussion, conceptual argumentation about the nature of the universe, it seems to me to be, you know, really ill-founded, and it's head of angels on the head of a pin stuff, and maybe we could do better if we could say, okay, well, how would we implement that? It can give me an example of a machine that would be doing the kind of thing that you're talking about. You'd say, oh, hey, look, that has free will, or it doesn't, and then we could argue about it. And in order to do that, all we have to have is a physical model of implementable systems that we could, if we needed to, if we had some disagreement, we could push the design onto that thing as far as we needed to go. And my worry, one of my many worries, is that people use conventional computers as that model. And so, you know, for example, you know, I like to bash on Wolfram because, you know, he thinks the universe is a cellular automata, but he thinks it is a deterministic synchronous cellular automata, like that. And, you know, again, I'm perfectly fine to say you could view the universe as a cellular automata, but that's a much weaker claim than what Wolfram and his acolytes tend to do. And so, you know, by picking an incredibly weak model of computation, non-deterministic, you know, no guarantees, you don't even know you're going to have progress, you just try. You're in a much better shape for trying to actually be able to implement these things and not just stumble over stupid mistakes, things that don't work because the universe is not deterministic. And even if it is deterministic in the overall, that is of absolutely zero use to us, and the stuff at the scale of machinery that we can build will never be deterministic because we cannot have complete enough knowledge. So whether or not the universe in principle is deterministic, it's not. But whether or not, any practical machine is not going to be able to lean on determinism and synchronous behavior in any critical fashion. And yet, that's the kind of computing we have now. We routinely depend on deterministic behavior and you know, complete synchronization, complete centralization, and you know, I feel like it leads people wrong. It leads people to have this, like I mentioned a little bit, you know, this kind of tech bro, master of the universe attitude, where they think, you know, we can be the center of everything, and we can control it all. We can, you know, all the threads come back to us at Facebook Server Central, Google Server Central, Amazon Server Central, whatever it is. We control it all, and it all goes back. And that is wrong, unethical, unhealthy for society, I think. So that's why I'm trying to, in addition to hack on Black Hole and build more demos, build more models, to back all this stuff up, I'm trying to figure out ways to express these ideas about alternate ways to compute that are much more sympathetic to bottom-up, self-organizing, collaborative, traditional living systems rather than fascist, authoritarian, top-down dictatorships. Okay, anyway, so that's my rant. So if it didn't make sense, yeah, what's that phrase? So if it didn't make sense in the T2sday update, then it'll be completely baffling now. And I think that's reminding me of a Tom Lehrer joke. So we just saw that he died in the last month. I like Wolfram's model, though, but it looks like a nightmare for communication and computing. And free the sim life, yeah. And I mean, you know, Wolfram's model is it's not even really Wolfram's model, right? It's just a traditional cellular automata writ large, and you know, all of the consequences that he claims for it are all consequences of pretending it's deterministic, pretending it's synchronous, and so on and so forth. You know, like pretending that the universality of cellular automata is going to help in some way, you know, in the actual running of the universe, you know, and anyway, but you know, at least it's distributed. At least it's spatially distributed. It's not just, you know, a CPU and RAM. So I can go with Wolfram that far. Anyway, okay. Maybe we can call it here, and I can try to go get a little sleep. Computation is a solid metaphor for science. Yeah, it's as good as anything, I think. And so the hypergraph model is the idea where you have every possible machine taking every possible transition, and that's the Rouliad. Is that? Am I way off like that? The rule is applied somewhere at random. Yeah. You know, I did look at some of Wolfram's stuff a little bit closely at one point, and there was one write-up which I found on the web. It was, you know, one of his essays rather than the book. That where he was talking about the Rouliad and wow, you know, gee, you are so big, so incredibly huge, you know, that kind of thing. And later in the essay, and this is what I've not been able to re-find, when I went looking for it, I couldn't find it again a couple years later, where, you know, he did take the next step. He said, okay, so, you know, this Rouliad idea is obviously utterly unimplementable. Because it's an infinity of infinities surrounding infinite things with infinite ways and infinite time and infinite space and infinite, my God, infinite infinities, like that. And he did start to say that there might be ways, you know, of making it useful, ways of, you know, stepping back from the all possible parallel of everything, and starting to get towards something that might actually be buildable, something that might actually matter in the universe in some way. And, you know, my problem with that is that once you do that, I mean, he's going to have to make a lot more steps in order to get to something that's actually implementable than he did in this essay that I recall, to the degree that I recall it. But once you actually get there, the problem is the Rouliad will have contributed nothing. The Rouliad will be the stone in the stone soup that has no nourishment, you know, if it serves as a nucleation point, that it all it has to do is to get people to come get excited and then work on this stuff, and then we'll get things that have nothing to do with, you know, infinitely branching cellular phenomena. They're not nearly infinite. They're not simulations of infinity. They're just actual machines, you know, that kind of thing. Then you know, okay, you know, if you believe in the stone and the stone soup story, and I want to believe in the stone and the stone soup story, but I don't want to mistake the stone for food itself. Efficient computer chip architecture. Is this a commercial thing, David, or is this just some people that are writing papers? I think he just wants to crack quantum gravity. Yeah, then what's he going to do for the evening? You know, you know, don't get me started on quantum. I have yet to see anything that has shifted me off my original skepticism about quantum computation and quantum speed-ups and all of that. And quantum gravity, well, or just quantum mechanics combined with relativity, and quantum gravity is as good a name for that as anything, I guess. Anyway, yeah, applying the rule at different places is like branching in the many world interpretation of quantum mechanics. Yeah, I get that, and the many world interpretation of quantum mechanics is as bankrupt, it seems to me, as the hypergraph, the Rouliad, and that sort of thing. physicists, they don't have any explanation that makes sense to our little minds. And you could say, okay, well, that's because our minds are so little, or you could say that there's something deeply broken in the framework that they've built so far that's going to mean nothing is going to make sense. Massively asynchronous, yes, thank you. Again, all massively classical computing, except that classical is normally assumed to be deterministic, and this is not going to be that, both because of lack of global synchronization and because of race conditions and failures, data failures, machines wearing out, broken, as well as bugs, as well as cosmic rays, as well as all sorts of single event upsets and so on and so forth. So, yeah, massively asynchronous computing, yay. Quantum computing, show me. Really, really show me. I mean, they were someone was claiming quantum supremacy a year or two ago, and then it seems to have kind of gone away. And I have, right? Am I mistaking that? I don't follow it closely enough. I just don't have time for stuff that I don't really believe in. It's like, a half good idea, I'd say, let's talk, but a no good idea at all, I say, let's talk in a few years. And that's where I am with quantum computing. Anyhow, okay, guys, and whoever is, yeah, I thought so. Whoever has been listening, I love chatting. I really do want to think about new ways of having multi-person interaction. Yeah, that was the room temperature superconductor, LK99. Working with developers, real silicon. I will look for efficient computer chip architecture, despite the name. I'll take a look. And we shall see what we shall see. Any last thoughts, comments, questions, rants, or raves before we shut it down for today? I do need to take a nap. I had a long night trying to make any of this stuff make sense, and it didn't do that well. Okay, all right. So I can put some hearts on this too, right? Because everybody can do it. And thanks for chatting, Ben. I appreciate you stopping in and yakking. It makes it all extra fun. You too, David, and Javier, and everybody who chips in. Okay, so I'm going to stop it, and I'll see folks back in the Discord for those who can tolerate that sort of thing. And we'll call it from there. Keith Hill, hi. And I don't know, have we met Keith Hill? But anyway, thanks for decloaking here at the end today. Okay, you too, David. Hope to see you next time. Step by step on everything. Okay. That's it. I guess I'll do another fade out, because why not?